Welcome back in lecture series on topic chemical thermodynamics. In last lecture, we have studied enthalpy of reaction, also standard enthalpy of reaction and guidelines for writing thermochemical equations. And today in this lecture, we will study standard enthalpy of formation and standard enthalpy of combustion and how to calculate standard enthalpy of reaction from standard enthalpy of formation. So all these points we will study today. So let us see first standard enthalpy of formation. So in last lecture we have studied this definition of standard enthalpy of reaction. In general, standard enthalpy of reaction is represented like this: delta H0R. This R is for the reaction. If the reaction is combustion, we have to replace this R by C. If reaction is neutralization, we have to replace it by N. If the reaction is for formation of a compound, we have to replace it by F, like this. So standard enthalpy of reaction is the enthalpy change, that means heat change, accompanying the reaction when reactant and products involved are in their standard state. So here standard state means the most stable form of that reactant or product. When pressure is 1 bar, temperature is 298 Kelvin, and if the reactant and product are in a solution state, then 1 molar concentration. So these are the standard condition, and under this standard condition, if reactant and product are in their most stable form, then during the reaction, whatever heat change takes place, that is called as what? The standard enthalpy of reaction. Now see here, the standard enthalpy of formation. We can write the definition of standard enthalpy of formation from standard enthalpy of reaction. So standard enthalpy of formation of a compound is the enthalpy change that accompanies a reaction in which 1 mole, this is most important, 1 mole of a pure compound in its standard state is formed from its element in their standard state. That means both must be in a standard state. The compound must be in a standard state and the element from which it is formed that must be in a standard state. And this is for 1 mole. We are considering the standard enthalpy of formation for 1 mole. So remember here, the standard enthalpy of formation of a compound is the enthalpy change that accompanies a reaction in which 1 mole of pure compound is in standard state, is formed from its elements in their standard state. Now for example, here water is the compound. When 1 mole of water in its standard state means in a liquid state, water is present under standard condition, water is present in the liquid state. So 1 mole of liquid water is formed from its constituent element, that is hydrogen and oxygen. In their standard states, hydrogen is present in a gaseous state and oxygen is also present in a gaseous state under standard conditions. So hydrogen combines with half oxygen in a gaseous medium, gives water in a liquid state. During this, whatever enthalpy change or heat change takes place, that is equal to what? Standard enthalpy of formation of water. That is compound water, and that is equal to minus 286 kilojoules. Now, this standard enthalpy of formation of water is equal to what? Standard enthalpy of reaction also. This is the reaction of formation of compound, and all the elements, that is reactant and product, are in a standard state, and it is a balanced chemical equation. So this is what the standard enthalpy of formation is equal to standard enthalpy of reaction also, and that is equal to minus 286 kilojoules. But this is not always, that means standard enthalpy of formation is not always equal to standard enthalpy of reaction. See how? See here, this is the reaction. Calcium oxide in a solid state reacts with carbon dioxide in a gaseous state and gives you calcium carbonate in a solid state. And during this, standard enthalpy of reaction, that is standard enthalpy of this particular reaction, is minus 178.3 kilojoules. Now see here, this calcium carbonate is in its standard state and 1 mole of calcium carbonate is formed in this reaction. But the reactants, that is carbon dioxide, is a compound and it is in a standard state. Calcium oxide is also a compound which is in a solid state, that is also its standard state. But this calcium carbonate is not formed from its element such as calcium, oxygen and carbon. It is formed from calcium oxide and carbon dioxide. And therefore, in this particular reaction, the standard enthalpy of reaction is not equal to standard enthalpy of formation. I think you understand this. So in this reaction, standard enthalpy of reaction is not equal to standard enthalpy of formation of calcium carbonate. Why? As calcium carbonate has been formed from its compounds and not from its constituent elements such as calcium, carbon and oxygen. So I hope you understood this difference between standard enthalpy of reaction and standard enthalpy of formation. Now, if you want to write a chemical equation for standard enthalpy of formation of methane, then how to write this equation? That is important because it is necessary to solve the numerical problems. While solving the numerical problems on standard enthalpy of formation, you should have to write this equation, thermochemical equation for the formation of that particular compound, and for that you should know how to write the equation for the formation of any compound. Now we will see two examples. Here methane is there. Now the standard state of methane is gaseous state. We have to prepare methane, 1 mole of methane gas in its standard state from its constant element. Now which elements are there? Carbon and hydrogen. And carbon in its graphite form, it is the most stable form of carbon. So carbon, whenever in a graphite form, it is a most stable form of carbon, and you know that hydrogen is in a gaseous state. So we will write the equation, chemical equation, balanced thermochemical equation for the formation of 1 mole of methane. So here carbon in a graphite form, we have to write plus hydrogen. 4 hydrogens are there, so we have to take here 2 into H2 gas gives you methane, 1 mole of methane. So this is what the equation for formation of 1 mole of methane gas, and during this delta HF is minus 74.8 kilojoules. Now see another example, methyl alcohol. Now methyl alcohol contains 3 elements, carbon, hydrogen and oxygen. So on reactant side, carbon must be there, hydrogen must be there and oxygen must be there. And you have to form what? 1 mole of methyl alcohol in a liquid form. Now carbon in its standard state, it exists in a solid form, hydrogen in a gaseous form and oxygen present in a gaseous form. So let us write this equation. Carbon in a graphite form reacts with how many hydrogen? 4 there. Hydrogens are there. So 2 moles are required. Twice H2 in a gaseous state plus oxygen. 1 oxygen atom is there. That means half mole of oxygen gas gives you 1 mole of methyl alcohol in a liquid state. So this is what the chemical equation for formation of 1 mole of methyl alcohol. And during this, whatever enthalpy change takes place, that is called as standard enthalpy of formation of methyl alcohol, and that is equal to minus 239 kilojoules. So like this you can write the formation of any compound. Instead of here the ethyl alcohol is there. Then how you will write this equation? Ethyl alcohol means C2H5OH. So C2, here we have to write twice carbon. Hydrogen 5 and C2H5. So here total 6 hydrogens are present in ethyl alcohol. So we have to write thrice H2 plus 1 oxygen. So half O2 gives you 1 mole of C2H5OH. Like this, you can write the equation for formation of a compound. Now, standard enthalpy of reaction can be calculated using standard enthalpy of formation. How? That we will see. So, while calculating the standard enthalpy of reaction from standard enthalpy of formation, the first rule which you have to use, you have to remember this condition. That is what? Standard enthalpy of formation of an element is always 0. Standard enthalpy of formation of element is always 0. For example, see here. Hydrogen. Hydrogen in its standard state, it is in the form of gaseous form. So, gaseous hydrogen, here the standard enthalpy of formation of hydrogen gas is always 0. Or standard enthalpy of oxygen, oxygen is in a gaseous state, so its enthalpy of formation is 0. If standard chlorine is present in a gaseous state, so standard enthalpy of formation of chlorine is 0. If nitrogen is there, N2, its standard enthalpy of formation is 0, like this. Then if sodium is there, metal, then it is present in a solid state under standard condition. So standard enthalpy of formation of sodium is taken as a 0. Or standard enthalpy of formation of zinc is taken as a 0. Or standard enthalpy of Fe, iron, it is in a solid state, so its standard enthalpy of formation is 0, like this. If mercury is there, then standard enthalpy of mercury in a liquid, mercury present in not in a solid state, it is present in a liquid state at normal temperature. So standard enthalpy of formation of mercury is 0. Like that bromine, bromine also is present in a liquid state at room temperature, and therefore standard enthalpy of formation of bromine is 0. Liquid bromine is 0. So like this, standard enthalpy of formation of an element is 0. Now why this standard enthalpy of formation of an element is 0? As there is no heat change when or during the formation of element from itself. Whenever an element is formed from itself, there is no change in heat content of the system, and therefore the standard enthalpy of formation of an element is always 0. Second condition, that is standard enthalpy of formation of a compound is equal to its standard enthalpy. That means standard enthalpy of formation of any compound is equal to standard enthalpy of that compound. How that we will see. Now you know that elements when gets converted into compound in their standard state, then the enthalpy change is known as standard enthalpy of formation. Now standard enthalpy of formation is equal to standard enthalpy of that compound minus standard enthalpy of that element. That means what? Suppose, see here, the water is a compound. It is formed from element hydrogen and oxygen in their standard state. Then the standard enthalpy of compound, that is water, minus standard enthalpy of element hydrogen and oxygen, sum of standard enthalpy of hydrogen plus standard enthalpy of oxygen is the standard enthalpy of the element. Now you know that in a standard state the enthalpy of formation of hydrogen is 0, and in standard state enthalpy of formation of oxygen is also 0, and therefore standard enthalpy of water is equal to standard enthalpy of water minus 0, that is equal to standard enthalpy of formation of that compound. Therefore, standard enthalpy of formation of compound is equal to standard enthalpy of that compound. So using this we can calculate what? The enthalpy, standard enthalpy of the reaction. See how? Here also therefore standard enthalpy of formation of water is equal to standard enthalpy of water, and that is equal to minus 286 kilojoules. Or also here carbon dioxide, standard enthalpy of formation of carbon dioxide is minus 393.5 kilojoules, and that is equal to standard enthalpy of carbon dioxide gas. Now the next, that is, see here how to calculate the standard enthalpy of reaction from standard enthalpy of formation. Now this is the reaction, general reaction. A moles of A reacts with B moles of B and gives you C moles of product C and D moles of product D. Now here A and B are the reactant, C and D are the product, and A, B, C, D are the coefficients of reactant and product. Now here for this reaction, standard enthalpy of reaction is equal to what? The standard enthalpy of the product. H0 represents standard enthalpy of C and H0D represents standard enthalpy of product D. So C into standard enthalpy of the product C plus D means number of moles, D into standard enthalpy of product D. Sum of these two minus standard enthalpy of reactant A and total standard enthalpy of reactant B, that is A into H0A plus B into H0B. So here H0A, H0B are the standard enthalpy of reactant, and H0C and H0D are the standard enthalpy of product. Now that means what? You know that standard enthalpy of formation of a compound is equal to standard enthalpy of that compound. Just now we have studied. So standard enthalpy of reaction is equal to what? C into H0C is nothing but C into that is standard enthalpy of formation of C. So C into delta H0F of C plus D into delta H0F of D. That is standard enthalpy of formation of D and standard enthalpy of formation of C. So sum of these two minus A into standard enthalpy of formation of reactant A plus standard enthalpy of formation of product reactant B. So this is what? The total enthalpy of standard enthalpy of formation of reactant, and this is total standard enthalpy of formation of product, and therefore here the standard enthalpy of reaction is equal to, remember this formula, it is most important formula while solving the numerical problem. So summation of standard enthalpy of formation of product minus standard enthalpy of formation of reactant. This difference between the standard enthalpy of formation of product and reactant gives you standard enthalpy of reaction. So like this you can calculate the standard enthalpy of reaction from standard enthalpy of formation of reactant and product. So next point, that is standard enthalpy of combustion. It is represented like this: H0C delta or standard enthalpy of combustion, delta H0C. Now standard enthalpy of combustion of a substance is the standard enthalpy change accompanying a reaction in which 1 mole, most important point, that is 1 mole of a substance in its standard state is completely oxidized. So enthalpy change takes place when 1 mole of a substance in its standard state is completely oxidized. Then during this, whatever heat change takes place, that is called as a standard enthalpy of combustion. That is delta H0C. It is represented like this. Now see here an example. Carbon in a graphite state, which is a standard state, plus oxygen in a standard state, gaseous state, gives you carbon dioxide in a standard state. So here 1 mole of carbon dioxide is formed from its element carbon and oxygen in their standard state, and the delta H0C, that is standard enthalpy of combustion of carbon, it is a combustion reaction as carbon is completely oxidized to give carbon dioxide, 1 mole of carbon dioxide. So here it gives you minus 395.4 kilojoules, and this is nothing but the standard enthalpy of formation also, because 1 mole of a compound is formed in its standard state from its element also in their standard state. And also this reaction is a combustion. Here is a complete combustion of carbon takes place. Carbon undergoes combustion or oxidize in presence of oxygen and forms carbon dioxide. So standard enthalpy of combustion of a substance is the standard enthalpy change accompanying a reaction in which 1 mole of a substance, that is 1 mole of carbon, in its standard state is completely oxidized. So here it is a standard enthalpy of combustion also and standard enthalpy of formation of carbon dioxide also. Then second example, see here, C2H2, that is what? The ethene, acetylene. Acetylene when reacts with oxygen, that means it undergoes oxidation or burn in presence of oxygen, then it gives you carbon dioxide and water. And here 1 mole of acetylene is oxidized and gives you carbon dioxide and water. So it is a combustion reaction, and therefore delta H0C is equal to minus 1300 kilojoules, and it is what? The standard enthalpy of combustion of acetylene, like this. So here also in this reaction, standard enthalpy of reaction is equal to standard enthalpy of combustion, and that is equal to, it is also the reaction heat of reaction also, standard heat of reaction also, and as well as it is a standard enthalpy of combustion also. So standard enthalpy of reaction is equal to standard enthalpy of combustion of acetylene, and that is equal to minus 1300 kilojoules. So standard enthalpy of combustion, one more point about this, that is it is always negative. See here the sign of both this reaction is negative as heat is evolved during the combustion, and therefore here the standard enthalpy of combustion is always negative. Remember that it is always exothermic process. Now see here how to write this reaction for combustion. Now if you want to write this reaction for combustion of methane gas, then methane should be burned in presence of oxygen. So here plus O2 gives you what? Carbon dioxide and water, and during this whatever heat change is the standard enthalpy of combustion of methane, and it is equal to minus 890.3 kilojoules. While writing this equation of combustion, you have to remember that you have to balance the chemical equation, that is most important. Now see here, when methane, in methane 4 hydrogens are there, so to balance this you have to add 2 molecules of water, and when you add 2 molecules of water, 1 carbon is there, so carbon gets converted into carbon dioxide. So here how many oxygens are there? Here 2 oxygen, and here also 2 oxygens, so here twice O2, so 4 oxygen. So you have to balance the chemical equation, that is important. Now if you want to write the combustion reaction for methyl alcohol, then methyl alcohol when it burns in presence of oxygen, it gives you carbon dioxide and water. Now you have to balance again what? Here 1 carbon is there, so 1 carbon dioxide is formed. 4 hydrogens are there, so 2 water molecules are formed. And to balance this oxygen, you have to multiply this by 3/2. Oxygen is how many oxygens are there? These two and these two. So 4 oxygen atoms are there. And here how many oxygen atoms are there? Only 1 and 3 by 2. So you have to balance it. So here 3 by 2 gives you what? That means 2 oxygen atom and these 2. So 4 oxygen atom. So here you have to balance the oxygen. And during this combustion is how much? Minus 72.6 kilo, minus 726 kilojoules. This much amount of heat is evolved during this combustion. Let's see here. Ethene, C2H2 gas, when it combines with oxygen, it gives you 2 moles of CO2 and 2 moles of water. Here you have to balance the oxygen. Here 3 moles of oxygen are required as 2 moles of water and 2 moles of carbon dioxide is formed. So here how many oxygen atoms are there? 2 oxygen, and here 4 oxygens are there. So 6 oxygen must be there, and therefore here 3 moles of oxygens are required, like this. So C2H4 when it combines with 3 moles of O2 gives you 2 moles of CO2 and 2 moles of water, and during this the heat of combustion, that is delta H0C, is minus 1410 kilojoules. This much amount of heat is evolved during this combustion reaction. So for example, see here this reaction, that is hydrogen in a gaseous state combines with half O2 in a gaseous state and gives you H2 in a liquid state, and delta, that is standard enthalpy of formation, is equal to minus 286 kilojoules. So in your textbook, try this. This reaction, this example is given, and you have to ask that whether this reaction is, that is standard enthalpy change of this reaction is the equal to standard enthalpy of formation or standard enthalpy of combustion or both. So here it is a standard enthalpy of formation as it is for 1 mole, and also it is a standard enthalpy of combustion as of hydrogen, because hydrogen reacts with oxygen, it is oxidized by oxygen. So 1 mole of hydrogen is oxidized, completely oxidized, and gives you water molecule. So it is a standard enthalpy of formation also and standard enthalpy of combustion also, and that is equal to minus 286 kilojoules. So this is about the standard enthalpy of combustion. Thank you.